Hey everyone. Okay, I'm going to go over and give you some hints for the 2.3.5 practice, and there's a couple questions I'm going to omit. So question 1A is in 2.1.1 page 12, 1B is 2.1.1 page 9 and 10. They're doing it with a hypothetical equation, okay? So these aren't actual elements or numbers, so you're just going to use like lowercase a's and capital A's, etc. in your equilibrium constant expression. For part C, for these two, look at 2.1.1, page 19 and 20. And for this one, look at 2.1.1, page 21. And for this one, look at 2.1.1, page 25. Question 2, acids and bases. For this one, look at 2.1.3, page 21. For B and C, they want the acid dissociation constant expression, not the number. Okay, so if you look at 2.1.3 page 21, you'll see exactly what they're talking about. And there's a little practice problem on there for you to do, and then do the same thing with this and write your answer as Ka equals whatever, just like you see it in the book. And then for C, they're asking about the base dissociation constant expression. So it'll be Kb equals something, and you're going to base it on this equation. So look at 2.1.3 page 22. You'll notice in this example that certain things are not included in the equilibrium constant expression, okay? For this one, these were all included because they're all aqueous. They're all dissolved. This is dissolved in water, this is dissolved in water, and this is dissolved in water. So anything that's aqueous, dissolved in water, has an AQ after it, sometimes in the equation, is included in the equilibrium constant expression. Gases are also included in the equilibrium constant expression. So if it's a gas, you would include it as well, because gases and aqueous solutions have changeable concentrations. You know, you could squeeze a gas into a smaller area to increase its concentration. Same thing with an aqueous solution. You can make it more or less concentrated. So those are included in B and C. All of these are aqueous, so they're all going to be included. The thing that's not included is solids and liquids, because solids and liquids don't have changeable concentrations, okay? So if it's a solid, you're not going to include it, and if it's a liquid, you're not going to include it. You'll notice H2O here is a liquid, okay? You can't change the concentration of water. Water is water, okay? You can't change its concentration, so water will not be included in your answer. So no liquids or solids are included in the equilibrium constant expression, and you'll see that in the example they have you do on that page. All right, and then for D, look at 2.1.3, page 23. Question 3, A, look at 2.2.1, page 8. B, look at 2.2.1, page 14. And C, look at 2.1.1, page 17. You only have to answer the first question, though. You don't have to answer the second question. And D, answer 2.2.1, page, you look at 2.2.1, page 20. For all of these definitions, these are in 2.2.3 pages 8 to 10. Question B is 2.2.3 page 14, and question C is 2.2.3 page 17. And then question 5A, some of this doesn't make much sense. Just answer this part. Identify what the hill on the energy curve represents, okay? That's in 2.3.1 page 11. B, these are found in 2.3.1, a variety of pages, page 12, page 21, page 7, page 9, and page 18. And then for A, 2.3.3, page 2. And then for B, I couldn't find this explicitly written in the text anywhere. What happens to the rate of the reaction as the reactants get used up? So think about it this way. As the reactants get used up, their concentration decreases. So based on what you read about concentration here in 2.3.3, page 3, you should be able to tell what this decrease in concentration, you should be able to tell what effect that has on the rate. And then C and D, you can omit those. All right, so hopefully that's helpful for 2.3.5 practice.